Okay, so in our last video, we factorized a function here, but they had given us our first factor. Okay, they didn't outright say what the factor was, but they gave us a root, and we know how to get a factor from having a root. Okay, so once they had given us that, it was really easy to find, well, what does that multiply by, to get me back to this original function. And then I just had to further factorize that. Okay, so when they gave me my first factor, it was easy enough for me to then go and say, okay, well, what's the missing factor? Okay, what does the factor they gave me multiply by to get back to the original question? In this question here, I've done it out that basically I haven't gotten the original factor. Okay, so what I need to do is find essentially the thing that they gave me in this question, which is I need to find a root. Okay, so let's just quickly recap on what a root is. Okay, so if I just have any quadratic, or sorry, a cubic, a root is anywhere that it crosses my x-axis. Okay, so this here is a root, this here is a root, and this here is a root. And they all have different x values. Okay, I don't know what x is at each of them at the moment. But what I do know is that whatever x is at those points, y is 0. Okay, so what I'm looking for in this function here is values for x that when I put them in for x, the whole thing ends up being 0. Okay, so that's what I'm going to be looking for in this question. So, I'm going to first try and find a root, and then that way I can use that to get a factor. Okay, I'm going to start off with the really obvious ones. So something like if x was 0. Okay, if x was 0, I don't even need to go subbing it in. Okay, let's just really quickly look. Well, if x was 0, then this full first term would turn to 0. This is also going to turn to 0 because I'm multiplying by 0, and this is also going to be multiplied by 0. So they're all going to turn to 0, and I'm going to get 18, which isn't what I want. Okay, I wanted to get 0. So now I can see, okay, well, what if I subbed in for 1? Again, super easy to do in our heads because 1 cubed is 1. So 4 times 1 is 4, minus 7 times 1, so minus 7. I'm at minus 3. I'm now at minus 24. Plus 18. So minus 24 plus 18 is still minus 6. So it's not minus 1. Okay, minus 2 gets a bit more complicated. Okay, so I'm going to try minus 2 and I'm going to do it out. So if x is 2. Okay, so let's try that. So my function is going to have x subbed in as 2 and everything else is going to be carried down. Don't know why that keeps happening. Okay, and then I'm going to have my plus 18 at the end. Right, so now that I don't have any variables left in this, I can just put it into my calculator, or if you want, you can do it out with BIMDAS. I don't have my calculator here, so I'm just going to do it out with BIMDAS really quickly. So inside my brackets, I don't have anything that can simplify. Then I move on to my indices. Okay, so that means that the multiplication isn't done yet. 2 cubed is 8. I wrote that down as a cubed, whereas I know I never have more than 1 power 3 in a polynomial, because then they could have simplified. So that's a squared. Okay, so that's 7 by 4 minus 21 by 2. So I can do that one out now if I want. Or I could have just left it as 2 plus 18. Okay, so I have 32 minus 28 minus 42 plus 18. Okay, so that's going to give me what? Minus 60 plus 40, so that's minus 20. Not what I was looking for. Okay, it is not equal to 0. So 2 is not a root. Okay, usually guys, when they don't give you that first factor, it is a small enough root that you can use. Okay, so I'd be quite surprised if x wasn't equal to either 1, 2 or 3. So I am kind of expecting this to work out now for me. But let's just see. So I'll get 4 by 3 cubed minus 7 by 3 squared minus 21 by 3 plus 18. Okay, so I'm going to get 4 by 27 minus 7 by 9 minus 63 plus 18. Okay, so that's going to be 108 minus 63 minus 63 plus 18. And that is equal to 0. Okay, so now we are on a very good, in a very good place, because we know x equals 3 is a root. Okay, and therefore what is the factor? So if we get this to equal to 0, it's a factor. Okay, so how do I get that to equal 0? Well, I'll just take 3 away from both sides. So x minus 3 is a factor. Okay, so now I know to start off the factorization of this question. Okay, I now know one of my factors. I know x minus 3 is a factor. Okay, but I need to figure out, well, what does x minus 3 multiply by to get me back up to this? Okay, so to get back up to this, okay, what does this multiply by? I'm going to do out a long division. So I have my 4x cubed minus 7x squared minus 21x plus 18. Okay, and I'm going to do out a long division with my first factor in there, the x minus 3. Okay, so if you know how to do your long division, you can pause the video now and try it. The first step is the first thing under the rectangle is divided by the first thing dividing. Okay, simple as. I'm not going to go through it in huge detail because I've done it in a lot more detail. I kind of explained it a lot slower in this last video here. Okay, so go back on that video there if you want it in more detail. It's just the first thing under the rectangle divided by the first thing dividing. So the x is dividing into the 4x cubed to get a 4x squared. Okay, what is that counting for? I'm going to re-multiply it by those two things so that I see it's counting for a 4x cubed minus a 12x squared. Okay, so what is left to be counted for? Well, I'm going to find the difference between my original and what I've just counted for. So I'm going to take this away. Okay, 4x cubed minus 4x cubed is nothing. Then I have a minus 7x squared minus by a minus 12x squared. Okay, so a minus by a minus is going to make that a plus. So it's a plus x squared. So I'll be left with a 5x squared. Okay, then nothing has been taken away from the x or the constant terms. So they are just going to be carried down. And then we start again. Okay, so the first thing, again, quotation marks under the rectangle. So this, what we're left with here to be counted for. Okay, so the first thing under the rectangle divided by the first thing dividing. Let's get a new colour. Let's just use red. So the first thing under the rectangle divided by that first thing dividing. And I get a plus 5x. Okay, what have I counted for by putting that 5x there? Well, I have to re-multiply to c. So I've counted for a 5x squared, and I've counted for a minus 15x. Okay, so what is left to be counted for then? Let's get a nice new colour. Okay, what is left to be counted for? So let's take that away from the line above. Okay, so the difference between these two, there is no difference, it's 0. The difference between these two, okay, so to get from here to here, I have to minus 6x. Okay, to get from that back to the original, or you can say minus 21x, minus by a minus is a plus 15x, so minus 6x, and then my plus 18 has had nothing taken away from it, so it's still there. Okay, now I do my method again. So my method again, you can get a new colour every time, or you can just, once you're used to these, just use the same colour. So method again, first thing under the rectangle, divided by the first thing dividing. Okay, so I'm going to get a minus 6. And then what have I counted for by putting that minus 6 there? So I'm going to re-multiply and see. So I have counted for a minus 6x and a plus 18. So what is left to be counted for? I'm going to take that away from the line above and see that there is nothing left to be counted for. Okay, so I have now figured out that to get 4x cubed minus 7x squared minus 21x plus 18. Okay, I have now figured out that x minus 3 multiplies by 4x squared plus 5x minus 6. Okay, is that fully factorised? So are both brackets factorised as much as possible? No. So I need to further factorise my quadratic. Okay. So to do that, I'm going to carry down what I'm not changing. Okay, so this other bracket that is fully factorised, and I'm going to factorise this. Okay, so I'm looking for what, it's not my easy quadratic to factorise now. Remember, the leading coefficient to this isn't 1. Okay, so it's not the easiest. You have to not just go to what multiplies to give minus 6, but actually do 4 by minus 6. So I'm looking for factor pairs of minus 24. Okay, and I'm doing it out that way. Okay, and I'm going to get then my factors are 4x minus 3 and x plus 2 when we do that out. Okay, it's worth noting at the start, okay, I found that x is equal to 3. You could have found that x was minus 2. Okay, I could have started this at the very start. I could have found that x being minus 2 could fill into that and give me 0. Okay, that would have been perfect. It would have just meant that I would have had a different quadratic left, okay, up here, because I would have been dividing by x plus 2 if I had found x minus 2 as a root. Okay, so if x was minus 2, then x plus 2 would have been a factor, and I would have been having a different quadratic up here. And then when I factorised it out, I still would have just gotten the other two brackets. Okay, so these three factors, they could be written in any order depending on what the first root you find is. Okay, yeah, and that's fine. Okay, as long as you end up with those three brackets at the very end, that's what we're looking for to have that fully factorised.